in this lecture video, our discussion point will be equivalent circuit parameters refer to the primary or refer to the secondary. And during analysis of transformer, it is usual to transfer the secondary parameters to the primary or primary quantities or primary parameters to the secondary for simplification of the equation or simplification of the analysis process. Now here in this equivalent circuit, you see the equivalent circuit here, exciting current is neglected, where this is the secondary, and this one is the primary. This is the primary coil and this is the secondary coil, whereas secondary parameters are R2 is the effective resistance of the secondary coil, Jx2 is the effective secondary leakage reactance. So whenever we will transfer these parameters to the primary side, there will be some problem, or the problem is that secondary voltage and current E2 and I2 are not equal with the primary voltage V1 and I1. So directly we cannot transfer the components or parameters to the primary side. So what we have to do, we need to do that whenever we are going to transfer to the primary side, refer to the primary equivalent secondary components we need to transfer. And we know that E1 is the primary induced EMF and E2 is the secondary induced EMF, equals to the N1 and divided by N2, and this is called a trans ratio. So from this equation we can derive that E1 equals to, from this equation we can write that E1 equals to E2, that means primary induced EMF equals to secondary induced EMF into trans ratio, or N1 divided by N2. So that means primary induced EMF will be equal with the secondary induced EMF when we will multiply the secondary induced EMF with a trans ratio, that is N1 by N2. Now if we take a resistance voltage drop here in the secondary, what is the resistance voltage drop in the secondary is I2R2. Is the resistance voltage drop in the secondary is I2R2. So similarly when we transfer or refer this voltage drop to the primary side, then we need to multiply trans ratio with this voltage drop, secondary voltage drop, trans ratio, that is N1 by N2. Now come to the point, secondary resistance drop, that is the resistance voltage drop. When we are transferred to the primary, then I2R2, that is the voltage drop, we are multiplying with the trans ratio N1 by N2. Now I2 equals to, so already also we know that I2 by I1 equals to N1 by N2. So that means I2, that is putting over here, I2 equals to I1 N1 by N2. So instead of I2 we can put this value and then we have R2 and N1 by N2. After simplifying this equation, we got this I1 R2 N1 by N2 whole square, that is I1 R2 dash. So R2 dash is the new resistance which is already transferred to the primary, and the value of the resistance will be R2 into N1 by N2 square. Similarly, if you transfer secondary effective leakage reactance voltage drop to the primary, so whenever we have transferred this leakage reactance voltage drop to the primary, then again the same way we need to multiply I2x2 with N1 by N2. N1 by N2 is the trans ratio. Similar way, if you put the value of I2, I1 into N1 by N2, we'll get this equation. I1 N1 by N2 square into x2. That is I1 but x2 dash. So x2 dash is the new value, and which is the secondary leakage reactance which is transferred to the primary, and then we got the value, that is the x1 dash. Now obviously x1 dash equals to x2 dash equals to x2 n1 by n2 square. This is the square. So this is the equivalent. So this is the methods by which we can transfer the value from one circuit to the another circuit. That is, secondary quantity we can transfer to the primary, or primary quantity we can transfer to the secondary. Now we know that our equivalent circuit, this is the equivalent circuit, this is already equivalent circuit, already you know exact practical transformer equivalent circuit, and this equivalent circuit we have V1 is the supply voltage to the primary circuit, R1 is the primary resistance, winding resistance, JX2 is the primary leakage reactance, I1 is the primary current, I1 dash is the counterbalancing current. Now IE is the exciting current, it is divided into two parts, core loss current, magnetizing current, and RC is the core loss component, XM is the magnetizing component, N1 into is the primary winding number of turns, N2 is the secondary number of turns, E1 induced EMF in the primary, E2 is the induced EMF in the secondary. Secondary leakage reactance JX2, secondary resistance, secondary winding resistance is R2. I2 is the current in the secondary, V2 is the terminal voltage, load terminal voltage, and load is connected. So this is the exact transformer equivalent circuit. Now, if we want to transfer the secondary parameters are R2, JX2, voltage, V2, E2, these all are the parameters. So when we are going to transfer this parameter to the primary, directly we cannot do that, as the voltage rating and current rating secondary and primary are different. So again, what we need to do, we need to multiply with the trans ratio. So come to the point, if you see here, this is the exact, this is the circuit, secondary quantity is transferred to the primary. Now new value we are getting, that is R2 dash, and obviously the R2 dash value will be R2 into trans ratio square, N1 by N2 whole square. So that this is the new value, and that value we can transfer to the primary, R2 dash, and the value will be equal to R2 N1 by N2 square. So this is primary equivalent, secondary quantity. Similarly, leakage reactance is JX2, which is primary equivalent secondary quantity. transfer this quantity to secondary to primary. Similarly, the I1 dashed. Now your I1 dashed. So we know that counterbalancing current. So I1 dashed N1 equals to the I2 and N2. That equation already we have seen. This equation is coming from this equation. Now similarly, if we transfer to the voltage E2, E2 when we are going to transfer to the primary side, this is the primary voltage side. So the voltage must be multiplied with the number of turns, that is N1 by N2. Secondary load voltage is V2, and if we transfer this to the primary circuit, then again we need to multiply with the N1 by N2. And this is the secondary components or secondary parameter R2 dashed, X2 dashed, and we can keep the this is E2 dashed. E2 dashed equals to E2 N1 by N2. V2 dashed, that is equals to V2 N1 by N2. And obviously this is the ideal transformer which is dotted over here. This is the load side. Ideal transformer which is dotted. So the parameter directly we cannot transfer to the another circuit. It may be a secondary parameters to the primary or primary parameters to the secondary. Before going to the transferring the parameters, we need to multiply with the trans ratio. So when we are going to transfer secondary side parameters to the primary, we need to multiply with the number of turns, that is I1 by N1 by N2.